coefficient test? All right, and I'm not going to write it out word for word, but basically you take a look at that, the leading coefficient and what the leading term is, and combine that with the degree of a polynomial, and you can do a pretty good rough sketch of this. All right, I need to let somebody in here. There we go. And when you hear that little ding, that means somebody's coming in. Okay. All right. So things that we need to know. We would need to know about the coefficient. The leading coefficient, basically, is it positive or negative? Because that's going to tell us a lot about the sketch. Then we would also need to be able to identify the degree, and that's going to tell us what kind of graph we're going to have as far as polynomial curves go, which is all we're going to look at. And between these two concepts right here, then what that gives us is that gives us our end behavior. All right. And I know probably if it's been a long time since you've done any of this kind of stuff right now, I'm not making any sense whatsoever. Give me time. Okay. Because I will get there and it'll all fall into place, hopefully. Okay. And then I'm also going to throw in something called turning points, because it just kind of helps. If there's an extra piece of information that you know that's going to help you sketch something, then that helps. So I don't think turning points are addressed in your book specifically, but it's an easy enough concept. All right, now two basic types of curves. All right, we're going to have polynomial curves. We're going to be sketching them, rough sketches, and basically they fall into two categories. So we're either going to have an x raised to an even exponent, or we're going to have x raised to an odd exponent. All right, now in those two scenarios, it doesn't matter what my even number is, and it doesn't matter what my odd number is. All right, what I do is if I see an even exponent, I always think, all right, in my mind, I think, oh, that's x squared. And then if it's odd, again, in my mind, I think, oh, that's going to be x to the third. All right, because I don't have to have every even one and every odd one memorized as to what they're going to look like, because they're all similar. All x to an even numbers are going to be similar. They're going to have similar characteristics, and same thing with x to the third. They're all going to have similar characteristics. Okay. Again, I am needing to let somebody in here. Okay, sorry for the interruptions. Okay, so with that in mind, then let's go a little bit farther. We know that x to the third, or x squared, are parabolas. All right, hopefully we know this is parabolas. And we have what? We have two scenarios, right? We have an upright parabola, okay, rough sketch there, or we can have an upside down parabola. Okay, those are only two ways parabolas can be. All right, now, if it's an x to the fourth, or an x to the sixth, or an x to the eighth, the only difference is we'll have more hills and valleys. All right, instead of just one little swoopy here, we'll have lots of hills and valleys, and I'll draw some of those here in a minute. All right, but basically, looking at this parabola, I have what's called up behavior. All right, and I literally think it's called up in my math lab. All right, I usually just do two up arrows to indicate that that's my end behavior. So when I said end behavior up here, I'm talking about the ends of the graph. All right, and then if this one, clearly we can see down, down, down. All right, and I'm pretty sure that your My Math Lab uses the phrases down, down. All right, but I usually just do a couple down arrows. Okay, and again, if it was an x to the fourth, an x to the sixth, you're just gonna have lots of hills and valleys in there. Now on the x to the third graphs, all right, I don't want to mix these up. Let's kind of box things off here. I've got two choices: an x to the third, basic x to the third, no shifting or anything, looks like this. All right, and then just as I can flip a parabola either upright or upside down, I can flip an x to the third with a negative involved. All right, so it would look like that. All right, and again, we've got some down, up, behavior going on this one, this would be down up in behavior. All right. And then if it's flipped around and we read left to right. So up comes first and then down. So this is up down into behavior. All right. But basically, again, if it's an x to the 5th or an x to the 7th or an x to the 9th, it's still going to have this general direction. It's going to have the same in behavior. There's just going to be lots of hills and valleys in here. All right. So let's take a look at some specific examples. All right. And honestly, to be able to do this, you kind of got to have all this memorized and be able to put it all into place all at the same time to be able to do this. Okay. So like, let's say I had maybe say, I don't know, it can be f of x, it can be y equals, it doesn't matter how I write my function here. Let's go with like a negative, say 3x to the 6th, I don't know, and then minus 2x to the 5th, and I put plus. It doesn't matter whether it's plus or minus, and then plus 10. Let's just say that's it. Okay, so obviously it's a polynomial curve. It's in standard form because my exponents are in decreasing order. This would be an x to the 0. All right, now if I apply this leading coefficient test, I'm going to look at my leading term. I'm going to look at the degree. I'm going to look at that coefficient, and I'm going to make some decisions based on what I see. Okay, so really, the rest of this doesn't matter. Okay, the rest of this does not matter. Okay, all I need to focus on is the leading term. That's the leading term. All right, now the first thing I'm probably going to do is I'm going to look and see what that exponent is. All right, it's an even exponent, right? So that means I've got a parabola looking thing going on. All right, parabola because it's even. It's not going to look like an x to the 3rd. It's going to look like an x squared because it's even. All right, then that definite leading coefficient there, that leading coefficient is negative. All right, so we know that when a parabola has a negative coefficient, it turns it upside down. So this one is going to be upside down. All right, which means it's going to have down, down behavior. So my end behavior is going to be down, down. And I did that because I looked at the 6. That's even. That tells me, oh, I've got a parabola thing going on. Negative coefficient means, oh, it's going to be upside down. But again, I had to have all that memorized to be able to get there. All right, now we have not really addressed turning points yet. I'm just going to do a rough sketch is what I'm going to do. I'm going to do a rough sketch here. Ooh, yep. Okay, so I know my end behavior is down, down. Okay, so if I'm doing a rough sketch, I would do this. All right, now, which means it's going to come up and do some swirly things and then come back down, right? So there's this rule about turning points. All right, so if this is an x to the 6th, I will have at most 5 turning points, one less than that exponent. All right, now I at most 5 turning points. I don't have to have 5 turning points. All right, it depends on actually the rest of that polynomial as to how many turning points I'll actually have. But if I'm just trying to do a rough sketch, all right, I'm not really trying to graph it, all right, I would probably go ahead and make sure it had 5 turning points. Okay, now what am I going to do here? So let's actually go to a blue here. Okay, so then I know down, down. So 1 turning point, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 5 turning points. I missed my little end behavior there, but here's my end behavior of down, down. All right, end behavior of down, down. Okay, and then 1, 2, 3, 4, 5. There's 5 turning points. Okay, now it's a sketch. All right, I don't know. What I don't know is, did I go up high enough? All right, maybe this was supposed to go up way high and then come way down, or maybe it was not supposed to go up that high. Maybe it was all, like I don't know any of that kind of stuff. All right, and when I do curve sketching like this in pre-calc, we actually find the zeros and make it cross at the right spot. All right, I don't know that that's a 0 of this function at all. All right, but I'm just trying to get the general shape. All right, I'm trying to teach you leading coefficient test and how we begin to do this process of curve sketching. All right, now why? Because on I don't usually on one of the tests or on one of the homework, they usually give you a matching scenario. All right. And when they give you a matching scenario, then you don't have to know about finding the zeros and being real precise. But if you have just this memorized, it's matching, you're going to do process of elimination. You're going to be able to match these things up. Okay. All right. So let's do a practice matching type scenario here. All right. That would apply this leading coefficient and the turning points and the degree. Okay. So let's call this matching. All right, now let's suppose I gave you, this is going to be really bad because I'm going to hand sketch all this stuff. All right, let's say I give you a function f of x, and it's a negative x to the fourth plus an x squared. And then let's say as a second function, I give you f of x is equal to an x to the third minus a 4x squared. Then maybe as a third function, f of x is equal to an x squared minus a 6x plus a 9. And then maybe an f of x equals a negative x to the third minus x squared plus 5x minus 3. Okay, so clearly I've made these really, really simple because I've kept the leading exponent kind of small. They're all in standard form. All right, now if it's a matching scenario, all right, this is generally what we do on one of our tests. All right, you're going to have 4 different graphs that you're going to have to choose from. So you won't be doing the curve sketching. You're just going to match the graph to the function using all of that information we just talked about. All right, so obviously me sketching this, not perfect here. And my sketches are going to be probably really bad, but let's suppose we had one that looked like this. And then another one that looked like this. And then maybe one that looked like this. And then one that looked like that. Okay, so I tried to keep my curves relatively, I got a lot of come and bleed through from that previous paper. All right, so obviously I've got here some sketches to look at. All right, pretty simple. Kept this on the simple part. All right, now what we're going to do is to do this type of matching thing on the first test. The only part of these functions that you need to look at is the first term. That is all you need. So it doesn't matter what is to the right. All of this doesn't matter, okay, because it is matching, and we're going to assume that these are the exact graphs. These are not sketches. I just hand drew sketches, but when you see it on the test, it'll be the actual curve that is being graphed. Okay, so what I'm going to do is I'm just going to go through and draw some conclusions. Now, we said if it was even, it's going to look like a parabola, right? Well, I hope that you can look at these 4 pictures and go, oh, well, this does not look like a parabola. This does not look like a parabola, but this one does. And this one looks like an upside down parabola. All right, lots of, hills and valleys in there, but still upside down parabola. So these two have to be even exponents. So I'm going to come over here and go, oh, well, the only 2 even exponents I have is for this one. All right, so this one has to look like a parabola, and this one has to look like a parabola. So my U's. All right, and then you're going to go through and go, oh, well, this one has a -1, which means I turn my parabola upside down. This is the upside down parabola. This is the right side up. So this upside down parabola, this has got to be B. And then this upright parabola has to be the positive leading coefficient there. Okay, so when it's matching, process of elimination. Okay, and then what I didn't mention on the x to the thirds, these are both x to the thirds. So those are basically your cubic equations. I didn't use that word before, but they are to the third power, so they are cubic. All right, now the regular cubic, all right, positive leading coefficient looks like that. So positive leading coefficient on the cubic looks like that. It is flipped instead of like the parabola flips top to bottom. All right, so a cubic, instead of flipping top to bottom, will flip left to right. So then when the parabola looks like this or has up down behavior, it's a negative leading coefficient. All right, so knowing that, then I can kind of come over here and go, yep, this has got the opposite in behavior, which is your cubics. All right, again, though, lots of hills and valleys, not tons of hills and valleys. All right, this one is the base one that has hardly none. This has a little bit. All right, but look at this in behavior. All right, this is down, up, right? Down, up. All right, well, this is down, up, which then means this has to have the positive leading coefficient. Okay, well, I have a positive leading coefficient, I have a negative leading coefficient. So that right there tells us which one's which. But if we want to analyze this, this is up and then down. All right, so this one is up first and down here. So then that one means this has to have a negative leading coefficient. Okay, so this one is my positive one. So this one has to be C, and then this one has to be D. All right, now, granted, that was a very simple one. Okay, just lost my mouse to let somebody in here. That one was a simple one. All right. However, there's probably not going to be more than 4. I could do up to 6, but it'll always be an even number, and I'll try to be really straightforward. We did not need to count turning points. All right, but could I have? Yes, I could have done turning points. All right, like on this one right here, there's 1, there's 2, there's 3. 3 turning points means that it could possibly be an x to the 4th, because you would have at most 3 turning points. Okay, so there is the x to the 4th. So number of turning points match there. Actually, turning points even match here. There's 1 turning point there on my parabola. Well, that's an x squared. Okay, so it has at most 1 turning point. Okay. All right, so are we kind of good there? It's a lot to take in.